Continuing our discussion on the semantic parsing, after we have seen the chunk parsing and dependency trees, we'll just analyze how best we can use the machine learning for the semantic role labeling process. So this topic is known as classification paradigm, where we'll be evaluating how we can use machine learning for semantic parsing. So semantic role labeling or semantic parsing is can be treated as a pure classification problem where we can classify each argument of a given predicate independent of each other terms. But some modifications have been proposed for this, some post-processing step to eliminate uh, the analysis which will not be possible, such as overlapping arguments. So those post-processing steps have been tried to improve the performance, but not much successfully. Basically, irrespective of those post-processing steps, a simple classification would be suffice for semantic role labeling. So Glidia and Jurafsky, they propose a two-step approach for semantic role labeling as a classification problem. So we know that there are two important steps in semantic role labeling or semantic parsing. Those two are, one is known as argument identification, another is known as argument classification. So those two process here we can see in the machine learning process. So firstly, we have to identify which are the arguments. So the algorithm will calculate the probability that a given constituent is an argument of the predicate or not. So we'll be evaluating the probability based on the two features, path and head. What is the path? Path from the constituent to the predicate in the syntactic parsing tree, and the head word is most important word that determines its syntactic role. So will calculate what is the probability of the argument given the path and predicate, probability of argument given the head and predicate. Then these probabilities are interpolated to generate the probability table. From the probability table, we will select or will classify the arguments. For example, John gave Mary a book. What is the predicate here? Obviously, the gave is the predicate. And the constituents are John, Mary, book. These are the constituents. Now we will calculate the probability of the John given the path, noun phrase and verb phrase and predicate gave, the probability of a book given the head word and the predicate. So once we calculate these probabilities, only non-zero probabilities will be considered, and based on that, a normalized probability is calculated by interpolating the probability distributions here, and based on that, feature sets will be labeled path, head word, position, phrase type. So from these features, we'll be calculating the probability. And once that probability table is generated, we can classify the arguments. So once we classify that, John will be classified as the agent and Mary will be as a recipient, book as the theme. Then the answer for that classification problem is John is classified as agent, recipient, Mary is classified as recipient, and book as theme. So two steps in machine learning process. One is argument identification, another is argument classification. Argument identification is done with calculating the probability given the path and head, Then once these are calculated, we will be interpolating these probabilities to calculate the rule or classification of the arguments. So two steps: argument identification, calculating the probability using features like path and head, then interpolating them to estimate argument probabilities. Argument classification, normalizing the probabilities and selecting the most probable label of a given argument. So we can use different types of classifiers for the problem of semantic role labeling. We can use decision trees C5, C4.5. Then we can use maximum entropy classifiers. Then we can use support vector machines, which are used by Pradhan and his team. And it was found that SVM exhibits more accuracy than other counterparts of the classifiers. So Pradhan et al. They have demonstrated better performance used on the prop bank corpus. So support vector machines, if you know, they are also called as maximum marginal classifiers, and to separate between two different classes, we'll find a hyperplane that maximizes the margin between the support vectors. So by nature, support vectors machines are binary classifiers, but here we have to classify multi-class agent, recipient, theme. This is a multi-class classification. For that purpose, generally, whenever an SVM is used for multi-class classification, there are two approaches. One is known as pairwise approach, one versus one, or which we call one versus O versus O. Another is one versus all approach. So in one versus one approach, suppose there are n classes. What we do is we train a separate binary class for each possible pairs, for 1 to 1 classifier, for 2 3 another classifier, for 1 3 another classifier. So total number of classifiers required will be n into n minus 1 by 2, and each classifier is trained only using the data points of those two classes. Suppose if there are three classes A, B, C, we'll be training A versus B, A versus C, B versus C. So classifiers are advantage is that classifiers are simple to train. They deal with two classes at a time, so there will not be any extension. It is a binary classification, but the problem is it requires more number of classifiers. If there are n classes, we require 45 classifiers indeed. This is known as one versus one approach. Then another one versus all approach. What we do is, suppose if you are if there are n classifiers, suppose you want to classify one, the remaining n minus 1 classifiers are taken as negative and only first class is taken as positive. So this is one versus all approach. So binary classifier is created for each class where the task is discriminate one class from all others. Suppose there are 10 classes. You are classifying the first one. The remaining 9 classes will be negative. Only one first class will be the positive. So this is one versus all approach. Suppose there are 3 classes. You will be training A versus B and C. B and C both are one class. A is another class. B versus A and C. A and C one class. B is another class. A and B one class. C is another class. So here we require only few classifiers when compared to the one versus one approach. But the problem is the classifiers will have to deal with imbalance in data because one class is being compared against largest set of all other classes. That will create an imbalance in the data. So these two approaches, among these two approaches, one versus all approaches was used by Pradhan because it was performing better. So in NLP, for semantic role labeling, we'll be using one versus all approach. So as in machine learning problem, any machine learning problem will be having two stages. training stage and testing stage. Training, where the SVMs are trained to classify the nodes from the syntactic tree. Then the testing stage, where the trained classifiers are tested with the new data. So training is computationally expensive because then as the number of examples increase, more time it requires and computational power also required. And one more concerning fact is that from the syntactic tree, most nodes are labeled as null. They are not what we say, they are not considered as arguments. So one effective technique is to prune, to remove all these null labels, null trees, null branches before we go for training. So the first step is null filtering. Reduce the number of nodes by by filtering out those that are highly likely to be null. So train the binary classifiers on the entire data set. Fit a sigmoid function to convert the scores into probability. This is known as flat scaling. And the probability of being null, if it is greater than 90%, then they are pruned from the training set. So this is one filtering step to improve the performance. And secondly, the training, where we'll be training the given classifier with the data provided. Then obviously the testing stage, where we'll be testing the given data. So earlier on the gold standard tree bank parsers, the performance was low, but then automatically generated parsers, that performance was high. So the important considerations here are: filtering process reduces training data significantly because we are eliminating all the null labeled nodes without impacting much on accuracy. Then pre-filtering during the testing also offers minor efficiency gains, but there is not much increased. But if you filter more and more, then that may have dampening effect on the performance.